All right. If you don't have it, it's really not that big of a deal. We were literally just doing that last question. I think I even gave you time to work on the last question, but we didn't go over the answers. So I think it's just good to just go over it together, make sure that we all have the correct answers on there, and then we'll be okay. All right. So we basically talked about like modeling, which is a fancy word for word problems, right? So basically, this whole section is all about word problems with linear equations. This class is more business oriented, right? It's literally created for the business school. So a lot of this was like business related. There was like a question on your test that dealt with cost and revenue and profit functions. So we learned all about that, which honestly wasn't that bad. It was just like remembering all the little stuff there. Then we started talking about other applications like systolic blood pressure and using the line of best fit to predict some values. And we did an example on that. And then we ended up on example number 8. Oh, here we go. That was from my last class. And then we left off on example number 8, which I gave you like 5 minutes to work through. And then we were like, okay, we don't have enough time to go over it. So why don't we just kind of continue this and make sure that we all have the right answers listed for example 8. So we're all good. So in example 8, we know that Y represents the average like spending on television services per year. And X here represents the number of years since 2010. Okay. What I want to do is I'm going to use these 2 data points. These actually happen in real life, or maybe they're 2 points on the line of best fit. And I want to figure out what the equation is relating Y to X. So since this is a linear equation, I guess we need to find the slope, right? And can someone remind me of that slope equation? Oh, well, that is the slope-intercept form, but yes, but the slope itself. Rise over run, or like y2 minus y1 over x2 minus x1. That was correct. I was just thinking about a very specific type of the slope equation. Okay, well, I can make 2x1 and 744y1, and the second point, oh my goodness, x2 and y2 over there. And then all we have to do is plug in, right? So we have 864 minus 744 on top. We have 6 minus 2 on the bottom. On the top, we're left with 120. On the bottom, we're left with 4. And this actually turns out to be a very nice number. We get 30. Yeah. All right, so that was finding our slope. Does anyone remember how to find the y-intercept? What do we pick? A point. Yep. So I'm just going to pick the first point. It really doesn't matter which one you pick, but I'm thinking that first point looks a little easier to plug in. I know that y equals mx plus b. And if I make 2x and 744y, we can plug this in to make 744 equals 30, which is our slope m, times 2, which is x, plus b. Okay, so we can go ahead and solve, right? 30 times 2 is 60 plus b, and we can subtract 60 on both sides to get 684 as my b value. And then finally, putting this all together, y would be equal to 30x plus 684. All right. Any questions on part A? Pretty good. I think we all did this on our test, so we're all good on this. But the problem with word problems is a lot of the times you're asked to like explain what your answer means, which gets a little tricky. So let's talk about what happens when we're asked to interpret the meaning of the slope. Well, first of all, what's the slope of the equation? Okay, you're getting like a little far ahead from me, but that's right. But what is the slope, like the number? 3. Yep. All right. So just looking at that number, it's like, okay, well, I don't really know what that means. Like, what is the slope actually telling us? And personally, for me, like, I can't really interpret it until I write it as a fraction. So another way to write 30 is 30 over 1, right? That's another way we can think about, well, any number, right? And thinking about slope, I know that slope is rise over run, or the change in y over the change in x. All right, and that makes it a little bit more clear, but let's take it into the context of the question. Remember, the question tells us that Y is the average consumer spending on television. So instead of writing Y, we can just X that out and write the change in spending, right? Okay. And then instead of writing X, well, X is the year since 2010. So this is the change in time in years, right? Okay. Now, writing it this way, is there anyone who wants to tell me what the slope actually means now? Let me give you a hint, okay? Since we're changing in X below, it's basically telling us what happens every 1 year, right? So as we, um, I don't know, go from 1 year to the next, right? Let me write this out. 1 year to the next. Do you think we're going to increase in spending or decrease in spending? Well, is it positive or negative? Positive, right? So positive means increase, right? So we would expect an increase in spending, right? And this is telling us by $30, right? Okay. So that's basically what the slope means. Personally, for me, if I'm ever asked to interpret the slope, I think it's easiest to write it as a fraction because then you can see like, okay, how is the y changing versus how is the x changing? And then it becomes really easy to be like, okay, well, if this is y and this is x, well, this is what it means, right? Okay. Any questions on interpreting the slope or anything like that? All right, last one. Part C, we're asked to use the model from Part A to predict the average consumer spending on television for the year 2024. Okay, so this is going to be a little different than the last page where we just plugged in a number. We actually are plugging in a number. 2024 is the time, so I guess this is our X value. But am I going to plug in 2024? No, what am I plugging in instead? 14, right? Because 2024, let's think about what X is, okay? X represents the number of years since 2020 or since 2010. Oh, this is a really low question, right? All right. So if X is the number of years since 2010, well, that means 2024 is 14 years since 2010, right? So we're actually plugging in 14 in for X instead of 2024. Let's go ahead and do that. Y equals 30 times 14 plus 684. I actually did this in my office before class, so you can check me on this, but I got 1,104 as my final answer. All right. Any questions on part C? All right. So this pretty much wraps up that last set of guided notes. Any questions on like modeling or word problems or anything like that? All right. Now, I personally don't really like word problems. I think this section was a little easier than most word problem questions. We're actually going to switch back to like math land and not applied land, but we will come back to word problems in a little bit. Soon we'll talk about like exponential functions and logarithmic functions. There's a lot of like applications in math with those that we'll talk about later. But for now, we're actually going to flip to a new section, which means we have a brand new set of guided notes. All right. All right. So we're going to talk about graphing. Personally, I think graphing, especially like for people who aren't like super keen to like math, I think like these graphing sections are a little bit easier than like the other sections. I don't know. Maybe that's just me. But we're going to talk about graphing. We actually learned about how to graph like straight lines before. That was pretty, well, it wasn't that bad. But we're actually going to be asked to graph a lot of different types of graphs in this class. And sometimes it's not just linear. Okay, sometimes these graphs have different shapes. Sometimes they'll look like a V, sometimes they'll look really strange. And we actually can draw different graphs without like having to plot all the points. There are very specific shapes of graphs that show up a lot in different math classes and in real life that, well, we'll need to be able to draw. So I think the easiest way to be able to draw these graphs is, well, learn the basic shapes of graphs and then be able to transform them, like stretch them, shift them, do whatever to them, maybe like reflect them across the x-axis, something like that, in order to draw like more complicated graphs. So we're not like just plugging in points to be able to draw something. And in this class, we actually have 8 graphs that we have to know the shape of, okay? I have them here, okay? Actually, your quiz for this class will be drawing these graphs by memory, okay? And, well, sometimes it's just easier to know the shapes than to plot each of the individual points. So what we're gonna do today is we're just gonna go through these graphs. I'll show you how to draw them and what the important like points in the graph are. And then, well, I'll have you memorize them for Friday. Okay, so let's start with our first one. The constant function. We actually have talked about the constant function before, but let's just kind of go over this. Okay, so basically the constant function is anytime we have f of x equal to just a number. So there's no x in the equation. It's literally just like y equals 6 or y equals 2, right? And we actually have talked about this line before, y equals 2. What does this graph look like? You did on your test. Yep. It's just a horizontal line on the x parallel to the x-axis, right? Anytime we have something that doesn't have an x in it, it basically just means it's either parallel to the x or like y-axis. But this time, since y equals 2, we're parallel to the x-axis. So basically, you just have to draw a line at y equals 2, okay? Maybe a point on this line will be like 0, 2, and then we can draw a line across this point, and this is literally our graph of the constant function. It's equal to 2 no matter what. Okay. Any questions on the constant function? All right, that one was pretty easy. Let's do the linear function, which is also pretty easy because we literally spent like an entire 2 weeks talking about linear functions. This time, y is equal to x. This is actually the most basic linear function that you can get because, well, the slope is just 1, right? And there's no like the y-intercept's just 0. So there's no like plus b going on here, okay? Now, I mean, of course we can just draw it, but let's just make a little table of x and y values in order to figure out what it looks like, okay? Now, I will say that for these graphs, I told you have to memorize them, but honestly, like when I say memorize, I just mean I want you to be able to reproduce them really quickly. So I don't want you to like, oh, like how do I draw this and spend like 10 minutes drawing the graph. So honestly, what I do is I'll draw an x and y table, plug in some x values and see what the y values are, and just quickly draw the graph from there. Okay, an easy x value is always 0. What will y be if x is 0 here? 0, perfect. What about when x is 1? 1. What about when x is 2? 2. What about -1? -1, right? This graph literally tells us like whatever x is, that's what y is. That's literally what this function is telling us to do. So I'll just make my x and y table here. We can plot some points. We really don't need to plot all the points I put here, but some points that I would look for if I was grading a graph like this is I would want the point at 0. I definitely want the point at 1 and maybe even the point at -1, just so it's very clear where the line goes through. And then I'll, well, continue my line out here. And there we go. All right. So this is my linear function. Okay. So on the quiz or whenever I ask you to draw these graphs here, what I really want to see is I want to see like at least 2 points on this graph, just so it's very clear what it's passing through. And I want to see the shape as a like diagonal line, right? Okay. All right, let's go to the quadratic function. We have talked about quadratics before. Don't know if we graphed one yet, but all right, let's go ahead and draw our x and y table for this one. Okay, some easy values are 0, right? What is 0 squared? 0. What's 1 squared? What's 2 squared? 4. Let's go to the negatives. What's -1 squared? 1, perfect. So it's positive, and like -2 would be +4. So let's just go ahead and draw some of our points here. We have 0, 0, 1, 1, 2, 4. And then the same thing on the negative side, okay? Now, when you draw this graph, it's very tempting to just kind of connect the dots and like make a very strange, oh my God, rickety? I don't know. Like whenever you have like jaggedy things, I guess it's rickety, right? I don't know. Maybe I'm just making up words. Is it rickety? I think it'd be rigid. Oh, like a rigid graph. Yeah. Um, yes. But if we plotted more points, which I mean, we just don't have time for, you would see that this actually has a very like curvy shape. It's not like jagged or rigid at all. It has a very curved shape and it actually has a U shape to it. Okay. So the quadratic function looks like a U. Does anyone know what that shape's called? It starts with a P. Parabola, right? So this is the parabola shape of a quadratic function. So on a test or quiz, I would definitely be looking for like these 3 points, the -1, 0, and 1 points. You can plot like the 2, 4 if you want, but we really don't need that. I just want to see these 3 points and then the U shape. So no like jagged lines going on here. All right. Let's take a look at the next one, the absolute value function, okay? Now, we actually haven't talked about what this is before, but basically an absolute value symbol is basically if you ever have a number, let's say like -2, okay? If you see an absolute value sign around it, they're these straight lines that kind of look like parentheses, but they're like straight, okay? They're not curved. And does anyone know what like the absolute value of -2 would be? 2. Okay. The absolute value symbols make a negative number positive. Okay. So -2 would turn into +2. Yeah, that's what I was just about to ask. What about the absolute value of 3? Does anyone know what this would be? Just 3. Okay. Yeah. So it basically turns everything positive. If it's already positive, then nothing happens. What about the absolute value of 0? It's just 0. Yeah. Okay. Yeah.
What about like a variable? So if it's like negative, would that just become positive?
Oh, yeah, that's a good one. Like the absolute value of -x would be positive. Actually, ooh, okay, this gets a little more complicated. Let's just say the absolute value of x. Okay. This will literally, this is called like a piecewise equation where it's one thing if there's something true and another thing if it's not. It basically becomes x if x is positive, and it becomes -x if x is negative. So that's kind of like the definition of an absolute value of a variable. But we won't get into that. That gets into like further versions of math. I was about to tell you something wrong. All right. Any questions on these guys? Okay. Well, why don't we go ahead and make our table here, x and y values. Well, I just said that the absolute value of 0 is 0. We can plug in 1 and 2, and we'd get back 1 and 2. I can plug -1 and -2 in. What's the absolute value of -1? 1, +1, good. Absolute value of -2 is +2, and we can go on doing that. So let's just plot our points. We have 0, 0, 1, 1, 2, 2, -1, 1, -2, 2. And of course, we can connect the dots using our lines. And this actually is a jagged or rigid graph, okay? It basically is the linear graph, but the negative version is like flipped up. And it looks like a V, okay? So this has a very like V shape to it. It has a hard corner at 0. Okay, so if I were to ask you to graph this one, I would ask you to plot at least 3 of these points, like the 0, 0, 1 negative, 1 positive, and I'd want you to show that like V shape with no curves. I do get really picky with how you draw it, so make sure it's like a V shape. Okay. All right, these guys were pretty easy. By the way, when I say I need you to like memorize these, like I know I kind of harped on this already, but it's not like you have to memorize everything. Like, okay, I need to memorize that like these 3 points go there. Um, Really, all you have to do is just think about like what are the x and y values, maybe even make a chart, and be able to recreate the graph in like I don't know a minute or something like that. Like you don't have to memorize each of the points. Okay. All right. square root function. I don't think we talked about this one yet. The square root of x, remember, is just like a fractional power to the 1/2. Let's see what happens here. Okay, let's make our x and y chart. Okay, what's the square root of 0? 0. What's the square root of 1? 1. That was kind of tricky. I would ask you the square root of 2, but it's going to be a decimal. So let's kind of skip over that because it's not going to help us to graph a decimal because it won't be very precise. The next number I know the square root of is 4. And what's the square root of 4? 2. All right. Let's go into negative numbers. What's the square root of -1? Undefined, right? You actually cannot take the square root of a negative number, right? If you type it in your calculator, it'll be like, oh, there's an error. Doesn't happen. So the square root of any negative number is undefined. Okay. -2 would not work, right? -3 would not work. -0.5 will not work. So basically the square root function doesn't exist when x is negative, right? It just isn't there. Okay. So how do we draw this? Well, let me plot my points. 0, 0, 1, 1, 4, 2. Okay. And basically what happens is on the left side of the graph, there's no graph because, well, the function is undefined everywhere before x equals 0. Okay. Now, when we connect the dots, this is a very smooth curve. The square root function is actually it's very related to the square function, the parabola. So it basically looks like a parabola turned on its side without the other half. Okay. So if we were to kind of draw like a U shape, like a half U shape, I guess, that's what the square root function looks like. Yeah. So I know it looks kind of awkward because there's nothing on like one side of the graph or on the bottom, but this is the square root function. If I asked you to draw this on a test or quiz, I would want these 3 points. So I want the 4, 2, the 1, 1, and the 0, 0, and I want that curvy shape going up. All right. Any questions on the square root function? Sounds good. All right, let's get a little more funky. We have 1 over x. Now, we really haven't talked about these guys. Whenever we have x on the bottom, it's called a rational function. This is a rational sort of thing. The next one is as well. Okay, and let's just see what happens with this 1 over x function. Let me make my x and y chart. Okay, let's plug in x equals 0. What's 1 over 0? Not 0. It's actually undefined. I actually forget. For some reason I always think 1 over 0 is just 0. But just imagine taking a pizza and cutting it into 0 slices. That's literally what you're asking when you do 1 over 0, right? So 1 over 0 just is not a thing. It is undefined. Okay, so our function is not going to exist when x equals 0, right? Which means, well, I'll show you what happens at x equals 0. All right, let's do when x is 1. What's 1 over 1? 1. When x is 2, what's 1 over 2? 1/2. Okay, and I guess when x is 3, we have a third. And when x is 4th, I guess we get a 4th, and then a 5th, and a 6th, and a 7th, and 8th. So if I were to draw just that part of the graph, well, I have 1, 1, right? I have 2 comma a half. I have 3 comma a third. I have 4 comma a fourth. 5 comma a fifth. Do you think I'm ever gonna reach 0 here? No, right? When x is a billion, it's gonna be 1 over a billion. It's gonna get closer and closer and closer and closer, closer to the x-axis, but it's never actually going to touch the x-axis. Now, yeah.
Do negative numbers not exist in this?
We'll talk about the negative numbers. But it's basically the same thing. We just haven't, I don't know why I stopped here. All right. So when I draw this graph, the graph, I know it looks like it's going to touch the x-axis because I can't get that precise, but it's going to get really close to it, but it's not going to touch it. Does anyone know what it's called on a graph? Yeah, right. So basically what happens here is the x-axis, it's what's called an asymptote, okay? And let me write that out so you know how to spell it. Asymptote, okay? And it describes like an imaginary line on the graph that the graph gets really close to, but it never actually touches it, okay? So this graph will get closer and closer to the x-axis, but it will never touch the x-axis ever, okay? All right, let's do negative numbers. When x is -1, what is y? What's 1 over -1? -1. What's 1 over -2? -1/2, and then -3 is -1/3. So basically the same thing is happening on the other side, except we're starting at -1, -1. And then now we're getting closer to the x-axis, but we're going from the negative side of things. So we're getting closer and closer and closer to the x-axis as we move to the left of the graph, okay? And we can connect the dots here as well. So it looks like the x-axis is an asymptote on the other side as well, right? Okay. Well, let's think about what happens in between, right? I know that the graph doesn't exist when x is 0, but let's think about what happens when x is, I don't know, a half, okay? Well, when x is a half, or 0.5, right? That means y is 1 over 0.5, which is 2, okay? And when x is 1/3, or 0.333, that means y is 1 over 0.333, which is, I think it's just 3, no? Yeah, it's just 3, right? And then when x is a fourth, it's 4, and when x is a fifth, it's 5. So it looks like as we get closer and closer to 0, my graph is getting closer and closer to the y-axis, right? Which means my graph is going up this way. Do you think I'm ever going to touch the y-axis? No, right? It's going to get really, really, really close, but it's never going to touch it, which means the y-axis is also an asymptote as well. Okay, so here we go here. So the 1 over x function has both a horizontal and vertical asymptote. That's what we call it. The x-axis and y-axis are things that we get close to, but we never actually touch it. Okay, the same thing happens on the negative side. We get closer and closer to the y-axis on the left as well. Okay, so this is kind of a funky shape, right? Basically, the 1 over x function has this weird shape where like one of them kind of curves up and the other one curves on the other end. I do want you to like know this shape, okay? So you should know this shape. When I ask you to draw the graph on a test or quiz, I definitely want you to plot, you don't have to plot all the points, but you should definitely plot the 1, 1 and the -1, -1, okay? I want to see this shape and I want to see the asymptotes with dotted lines. So you should draw the asymptotes in with the dots. Okay. Let's go to 1 over x squared. All right. So this is also a rational function. I think you might be thinking now that there might be an asymptote here, which there is. Okay. Let's plug in some x values. When x is 0, what do you think y is going to be? Undefined, right? 1 over 0 is, well, undefined. Undefined. Okay. When x is 1, what do you think y is going to be? Well, it's 1 over, oh, yeah, 1 over 1, which is 1. What about when x is 2? 1/4, good. And then when x is 3, we have like 1/9. So it looks like here we're also getting that asymptotic behavior where we're getting closer and closer to 0, but we're never actually touching it, okay? The same thing happens for -1. Are we going to get negative values or positive y values for the negative x values? Positive, right? Because we're squaring them. We're actually going to get the same values, but they're just going to be, well, with negative x values. Okay. So when I graph this, I'm going to be kind of lazy. I'm only going to graph the 1, 1 and the -1, negative, or, oop, that's a wrong one. I did that wrong, didn't I? -1, comma 1, right? I'm definitely going to have an asymptote at x equals 0, okay? And we're also going to have an asymptote at y equals 0, okay? So basically what this graph is it's kind of different than the first graph, but it basically has the same shape. On the left hand, or on the right hand side, we have the same shape as the previous graph. On the right hand side, it's slightly different because now we're on the positive part of the y values here. So it basically is the same shape, but it's in a different like quadrant or section of the graph. Okay. So this is what my 1 over x squared function looks like. If I asked you to draw this on a test or quiz, this is literally what I'm looking for. I want the 2 points here. I want the overall shape, and then I would want you to draw the asymptotes using dotted lines. Okay. Any questions on these guys? Not on the quiz, but we will get there this week. All right, last one is the cubic function, x cubed. Let's go ahead and draw these guys. We have our x and y values. Let's do x equals 0. What is 0 cubed? 0. What's 1 cubed? 1. What's 2 cubed? 8. Good. If you're a computer science major, like you're really good at doing like powers of 2. So 2 cubed is 8. Anyone know what 3 cubed is? 27. Good. It's 3 times 3 times 3. So 9 times 3 is 27. Okay. Let's do the negative numbers. What's negative 1 cubed? Negative 1, right? When you cube a negative, it stays negative because you're multiplying it by itself 3 times. So the negatives don't cancel out. Negative 2 cubed would be negative 8. And I'm going to kind of stop there. Okay. Let's go ahead and plot our points. We have 0, 0. We have 1, 1. We have 2, 8, which kind of goes off our graph. Maybe I'll plot a point like all the way up here just so I have it in mind. We have -1, -1, and -2, -8, which I don't know, probably further down than that, but there we go. Okay. Now, the shape of this graph, I wasn't very precise here. Don't connect the dots using like jagged straight lines. This graph is very curvy, okay, very much like the quadratic function. And this is what it looks like. Basically, this graph kind of curves up to get to 1. To get from 1 to the next one, well, you have to go all the way up, which we don't really have a point for. So it kind of just shoots up after x equals 1. And it does the same thing in the opposite direction on the negative side. So it curves down and then it shoots down after that. Okay. The way I like to memorize the shape for this one is it looks like a disco man, right? Like, that's like how I remember the shape. If I were to ask you to draw this shape on a test or quiz, I would want these 3 dots here. And then I'd want the disco man shape drawn out. All right. Any questions on the graphs? All right, so on the quiz today, or not today, on Friday, I'm gonna give you this. Like, this is your quiz. You're just gonna recreate the graphs on your quiz. That's pretty much what the quiz is gonna be. I was gonna start this today, but I didn't do this in my last class. So what do you think about leaving just a little bit early today?